In this video, we'll take a look at log amplifiers, an amplifier which outputs the natural logarithm of the input signal. We'll also see how to change this into an antilog amplifier. You might have guessed that we need a device which has a logarithmic or exponential IV characteristic. Can you think of which device follows a logarithmic relationship? It's none other than a bipolar junction transistor, or BJT for short. A BJT has three terminals: the base, emitter and collector. The current through the collector IC is given by Is into the exponent of QVBE by KT-1. Here K is the Boltzmann constant and Is is the saturation current of the BJT. Let's try putting this BJT into the feedback loop of an op-amp and see what happens. The op-amp is in negative feedback and hence V- is 0 volts. By Ohm's law, the current through the resistor R is V and by R. The current IC is given by Is into the exponent of QVBE by KT-1. These two currents are equal as no current flows through the input of the op-amp. Equating these two we get usually E raised to QVBE by KT is much larger than 1 and hence we ignore the 1. VBE is VB minus VE. VB is at zero potential and VE is equal to Vout. Hence VBE is equal to minus Vout. Rearranging we get, V in by ISR, is equal to exponent of minus Q Vout by KT. Taking log on both sides, Vout is equal to minus KT by Q, into log Vn by ISR and hence, we have successfully gotten the log of the input voltage. Remember that this is the natural logarithm, which means to the base e and not the base 10. Now, we want to change this into an antilog amplifier. Antilog is just the inverse operation of log. Have we seen how to adjust circuits for inverse operations before? Yes. If you recall, when we wanted to convert an integrator into a differentiator, all we did was switch the position of the resistor and capacitor. We use a similar approach here. To convert this into an antilog amplifier is quite easy. Just switch the positions of the BJT and the resistor. Vout by R is the current through the resistor. Note the direction of current IR. Using the current voltage relationship, the current flowing through the collector of the BJT is. These two currents are equal and hence we get. Here VBE is equal to minus Vn. Hence, we have Vout by R equals Is, into exponent of minus QVn by KT. An exponent is the same as an antilog. Hence, Vout is equal to antilog of minus QVn by KT into ISR and hence, we now have the antilog of the input signal. Logs and antilogs are complicated mathematical functions which require a calculator to be computed. However, by simply using an op-amp and a BJT we have a circuit that gives the real-time logarithm of an analog signal. That's all for this video. If you have any doubts, please ask in the comments section below. Don't forget to like, share and subscribe.